In this video, we are going to solve absolute value problems and problems in linear inequalities. Let's consider this problem. The absolute value of 2 minus 3x divided by 1 plus 2x less than or equal to 4. So we'll go about this by removing the absolute value sign. So 2 minus 3x divided by 1 plus 2x is less than or equal to 4. Then we'll cross multiply. So if we cross multiply, it becomes 2 minus 3x is less than or equal to 4 times 1 plus 2x. So 2 minus 3x is less than or equal to 4, then plus 4 times 2x becomes 8x. We can group like terms at this point. It becomes 2 minus 4 is less than or equal to 8x, then plus 3x. So 2 minus 4 is 2. 2 is less than or equal to 8x plus 3x is 11x. So if we divide through by 11, we divide here 2 by 11, we find out that x is greater than or equal to, here 2 minus 4 is minus 2. So it becomes minus 2 over 11. The second aspect is to find the negative, because remember that we've already established that the absolute value of x is x, and then the absolute value of negative x, the absolute value of negative x is also x. So we need to find the absolute value of the negative of this, and therefore this is equal to 2 minus 3x divided by 1 plus 2x is less than or equal to minus 4. So 2 minus 3x is less than or equal to minus 4, then times 1 plus 2x. 2 minus 3x is less than or equal to minus 4 times 1 is minus 4. Minus 4 times 2x becomes minus 8x. Let's group like terms. It becomes 2 plus 4 is less than or equal to minus 8x plus 3x. 2 plus 4 is 6. So 6 is less than or equal to minus 8x plus 3x is minus 5x. So we need to divide through by minus 5 and divide here 2 by minus 5. So at the end of the day, we find out that x, since we divided by minus 5, we change the sign. So x is less than or equal to minus 6 over 5. So at the end of the day, the values of x are x is greater or equal to minus 2 over 11, or x is less than or equal to minus 6 over 5. So we are supposed to find x in this equation. Absolute value of x plus 6 is less than absolute value of 3x minus 24. Now, so let's write the question, which is absolute value of x plus 6 less than absolute value of 3x minus 24. So we'll remove the absolute values and solve it. So x plus 6 is less than 3x minus 24. So let's bring x to the right hand side and take 24 to the left hand side. It becomes 6 plus 24 less than 3x minus x. So 24 plus 6 is 30, which is 30 less than 3x minus x is 2x. So if we divide through by 2, we find out that x is greater than 15. Now, the next thing is we need to find the negative of this. So this one becomes x plus 6 equals minus into brackets 3x minus 24. So this becomes x plus 6 equals minus 3x. Then minus 1 times minus 24 becomes plus 24. So let's bring 24 to the other side. Let's take 3x to the other side and bring 6 to the right hand side. It becomes x plus 3x equals 24, then minus 6. X plus 3x is 4x equals 24 minus 6 is 18. So we divide through by 4. Find out that x is equal to 9. Sorry, this is a less than. I forgot to bring the sign. The sign is less than sign. So let's repeat the signs here. So x is less than 9 over 2. So let's draw a number line to find out if this is true. So let's assume here is 9 over 2, and then this side is 15. But because it is less than, then it means that 9 over 2 and 15 are not part of the values. And therefore, let's test for values less than 9 over 2. 9 over 2 is around 4.5. But let's choose a value like 0. So let's put 0 into this equation. So absolute value of 0 plus 6 is less than absolute value of 3 times 0 minus 24. So this becomes 0 plus 6 is 6. So absolute value of 6 less than absolute value of 3 times 0 is 0 minus 24. So in other words, 6 is less than 24. And this is true. 6 is less than 24. And therefore, this region is one of the required regions. Now, let's take a value between 15 and 9 over 2. Let's take a value like 9 over 2 is 4.5. So let's take 5. 5 is within this region and test it. So 5 plus 6 is less than 3 times 5 minus 24. Well, 5 plus 6 is 11. Absolute value of 11 less than 3 times 5 is 15. 15 minus 24 is 9. And it is not true because absolute value of 11 is 11 less than absolute value of 9, which is 9. 11 is not less than 9, and therefore this region is not one of the required regions. Now let's take values greater than 15. For example, let's take a value like 20, because 20 is greater than 15. So it becomes absolute value of 20 plus 6 less than absolute value of 3 times 20 minus 24. So 20 plus 6 is 26 less than 3 times 20 is 60 minus 24. So absolute value of 26 is 26 less than 60 minus 24 is 36. And it is true that so absolute value of 36 is 36. So 26 is less than 36. And this is a true statement. So the regions here, so at the end of the day, this is the required region. And therefore, the values of x are x less than 9 over 2 or x greater than 15. So these are the range of values of x for which this equation can stand. So we have another question here, which is 1 over x minus 4 is greater than x over x minus 6. We are supposed to solve for x. So this is also another clear example of linear inequalities of rational functions. So what we need to do is to bring this term to the left hand side. It becomes 1 over x minus 4 minus x over x minus 6 greater than 0. Let's find the LCM, which is x minus 4 times x minus 6 greater than 0. So here becomes 1 times x minus 6, then minus x times this side becomes x minus 4 greater than 0. So let's distribute. It becomes x minus 6. Then minus x times x is minus x squared. minus x times minus 4 becomes plus 4x, and divided by x minus 4 then times x minus 6 greater than 0. So x here becomes minus 6, then x plus 4x becomes plus 5x, then minus x squared divided by 2 bracket x minus 4, then x minus 6 is greater than 0. Let's try and factorize this equation. You can see that minus 1 times minus 6 becomes plus 6. So we need two numbers that when you multiply together, you are going to get 6. But when you add, you will get 5. And those numbers are 2 and 3. So the equation becomes minus 6 plus 2x plus 3x minus x squared divided by x minus 4 then times x minus 6 greater than 0. Let me continue from here. So you can factorize. If you pull out 2x, so you can factorize 2 from here, actually minus 2. So this equation becomes 3 minus x, and then you can factorize 3x here. Sorry, you can factorize x out from here. Here becomes 3 minus x. So at the end of the day, sorry, here is plus, so plus x, because we are factorizing x from this side. It becomes divided by x minus 4, then x minus 6 greater than 0. So it becomes x minus 2 in one bracket, then times 3 minus x in another bracket divided by x minus 4, then x minus 6 greater than 0. So you can see that we have this constraint here. X cannot be 4 and x cannot be 6. And we also have 2 and 3. So let's try and represent this on a number line and shade the required regions. Let's assume this is our number line, and here is 0, 2, and then 3, 4, and 6. So let's take values less than 2 and insert them here. So let's assume that 0. If we put 0 here in this equation, we find out that 0 minus 2 is a negative number, and then 3 minus 0 is a positive number divided by 0 minus 4 is a negative number, and then 0 minus 6 is also a negative number. So at the end of the day, we are going to get a negative number. However, we are looking for positive numbers because the equation must be greater than 0, and therefore this region is not a required region. Let's take values between 2 and 3. For example, 2.5. 2.5 minus 2 is a positive number. 3 minus 2.5 is a negative number divided by 2.5 minus 4 is a negative number, and then 2.5 minus 6 is also a negative number. Sorry, I made a mistake. 3 minus 2.4 is a positive number, so this side is going to be a positive number. So a positive number times a positive number is a positive number. Negative number times negative number is a positive number. Positive number divided by a positive number is a positive number, and therefore this region is one of the required regions. Let's take values between 3 and 4. For example, 3.5. 3.5 is between 3 and 4. Let's insert 3.5 here. 3.5 minus 2 is a positive number. 3 minus 3.5 is a negative number divided by 3.5 minus 4 is a negative number, and 3.5 minus 6 is also a negative number. So at the end of the day, we are going to get a negative number, and therefore this is not a required region. Let's take values between 4 and 6. Example 5. 5 minus 2 is a positive number. 3 minus 5 is a negative number divided by 5 minus 4 is a positive number. And then 5 minus 6 is a negative number. So at the end of the day, we are going to get a positive number. And therefore, the region between 4 and 5 is also a required region. 4 and 6 is also a required region. Let's check regions greater than 6. For example, 7. 7 minus 2 is a positive number. And then 3 minus 7 is a negative number divided by 7 minus 4 is a positive number. And then 7 minus 6 is also a positive number. So at the end of the day, you are going to get a negative number. So regions greater than 6 is not a required solution. So we only have required solution in two places. That is 2 and 3. And then in union with this region, which is the region between 4 and then 6. So if we are supposed to write them in terms of inequalities, then x is greater than 2 but less than 3, or x is greater than 4 but less than 6. So these are the set of the values of x that satisfy this inequality.